Hello and welcome back to the first project in the OpenCV tutorial playlist. Up till now, we have discussed a lot of steps, a lot of functions in OpenCV which dedicated a particular task. But I thought, why not actually use these functions in a form of a project or something hands-on which have a better use case? So for that, I have this image right on my screen. It's a random receipt, and we're gonna build a document scanner which can actually recognize this image and display it in the manner we want it to. Inside my doc scanner directory, which have two files right now, one is the image file and another one is my scanned.py file. So first of all, let's start by importing all our libraries. So let's import NumPy, which is going to use for all the mathematical calculations and also all the image processing. Then let's quickly import CV2. Another library which we've used intensively in the past is Immutals. So I've imported all the three libraries. Another library which you need to install, and we did not discuss about this previously, is you need to work with Skynet images. So you can easily download it using pip3 install Skynet images, but since I already have it, I am gonna just import it. So from sk image dot filters, we're gonna use this later on with the project, but for now let's just import it. We need threshold local. Have all the libraries installed, so I'm gonna take a variable image, and using cv2's imRead method, let's just read the demo receipt or the image, and we'll put in the address of the image, that is image.jpg. Now, this image has its own dimensions, all right, and there is a lot of pre-processing which will be put in inside this image. So for that, rather than working on the original image, let's just compress or diminish the dimensions of the image just for the pre-processing part, so that it makes it more easier and convenient for the algorithms to figure out the extremes. So let's just find out the ratio of this particular image, that is diminishing the size by a certain aspect. So if you remember, image.shape returns three values, three of its dimensions. So right now, since we're dealing with the height, I have used the 0th parameter because we have 0, 1, 2, the second parameter being the RGB or the GBR value. So let's just divide it by 500.0 because it's a float value, so that we have the original ratio of the image, and this is also going to be used in the later part of the tutorials. Okay, but for now, since we are messing around with the original image, let's just make a copy of this image using image.copy method in OpenCV. All right, so there it is. And now I'm going to resize this image using immutals inbuilt function. So my image is gonna be immutals dot resize, and here you're gonna pass in the first argument, that is the image in itself, and which parameter are you gonna use for the resizing, and that is you want to resize the height of the image. So we have the original height over here, or the ratio at which we resized it, and this is our new image which is resized, which is reduced to 500 pixels. All right, so now every time whenever we work on image pre-processing, the first thing is converting the image to grayscale. So let's quickly jump over. We've done it multiple times. If you haven't, just go check out that tutorial. So using cv2's dot cvt color method, I'm gonna pass in the image as an argument, and change it to its color basically to be color should be changed from color to gray. So yeah, there it is. Alright, so we've converted the image to grayscale. That means the first part of the pre-processing is already done. And now we need to smoothen our image for, again, better pre-processing. We've discussed about this previously. So let's take another variable, that is smooth, and we do it using the Gaussian blur property. So cv2 dot there we had it, Gaussian blur, yeah. So this basically, helps us to reduce the noises we have in the image. Sorry, we don't have to pass an image, we have to pass in gray because that is the image we're going to work with. That will be the size of the blur we need, or the size of the smoothness we need. And another parameter 0. Alright, then I need to find the edges inside this image because that is what we are concerned about. Alright, this not the whole image but just our region of interest, or the part which we need. So let's take another variable edged, and using the canny edged algorithm, let's just detect the images in the edges in this image. So yeah, we've passed in all the parameters which were necessary. What do they do, how do they do, we've already discussed. I'm not gonna waste a lot of time in doing that out, but let's do one thing. We've done a lot of things. Let's just display this image. So using cv2's I am show method, let's it's an edged image, so let's pass in edged and the variable over here. And because it does not wait for anybody, let's just add the wait key. And yeah, let's run it and see what are we getting. Okay, and there you go. As you can see, it has reduced all the noises, and we just are left with the scanned part. All right, so the first step in the pre-processing is done properly. So that being done, another step that we need to do, is a very important step, is actually finding the contours. So for contours, again, CV2 has already done that for us. So we need to use the method find contour. Alright, what do we need to pass? We need to pass in the image we need to find the contours from, and contours can only be taken out of the edged image. So I'm gonna remove this because this might create some confusion. Alright, so we have our edged image over here, and for contour retrieval we have multiple methods for retrieving a contour. So for now, let's use the list method. Alright, so you can see we have these many. We have it in the form of a tree, we have it in the form of a list. So for now, we're going to use the list method, and then we were going to work with the chain approximations. So chain approximations again are of multiple types, whether we want all the contours or we just want the main points, everything linked above. So for now, let's just keep it simple. So it gives us the main point. Now I need to grab these contours, and that can be easily done using immutable's grab contour method, and we just need to put in the name of the variable which are holding all the contours of the image. So now, if we think about it, this image will have a lot of contours or a lot of defining boundaries. But what we need is, or what is our region of interest, and that is just this white sheet of paper. All right, all this is just waste for us because we need to filter that content out. So every document scanner is usually in the form of a rectangle only and has 4 points. All right, so we need to find the biggest rectangle, and we just pre-assume, for the sake of simplicity, that the first biggest rectangle that we're gonna encounter will be our document, or the document which needs to be scanned. So I have already grabbed the contour, but let's see how it looks. I'm gonna use the draw contour method. So this takes in the image as an argument. Now this image means whatever image you want the contours to be drawn on. The name of the contours which needs to be drawn, -1 signifies that we need to draw all the contours it encounters in this image, and the color of the contour and the thickness. So let's just run it or see what it does. So using cv2 I am show method. Alright, that's a full stop. cv2 I am show. Let's pass it draw because we are drawing the contours, and let's pass an image because now it's gonna use this image and draw everything on top of it. So yeah, use the wait key, and let's just wait for 0 seconds. Okay, let's rerun it. All right, so there you go. These are all the contours. You can see that there are so many edges. We don't need all that. All right, we just need this particular paper, and it has a lot of dimensions. So we need to do a bit of pre-processing on these contours. Let me just comment this part out. All three of them. Yeah. Now that being done, let's just sort these contours into descending order of their sizes, all right, so that we know that the first contour is, is at the beginning, and then we have all the contours following that. For that, let's take our variable cont again, and this time we need those contours to be arranged in a sorted manner, hence I use the sorted method. And over here, let's pass in the key. So key is basically on what parameters do I need to sort my contour, and for this matter, obviously it's contour area, because we are just concerned by that. All right, we need the first biggest four square area rectangle. So, alright. So now we need to select the reverse method. Now this basically means whether we want it in ascending order or descending order. So let's just slice it up using array operation. Now we have all these contours in a sorted manner, but what I need is I need to get each and every contour individually rather than getting all in a list. So I'm gonna iterate over each and every contour using the for loop. Now the thing is that these contours are not exactly in a perfect shape, and we need to use some approximations here in this image, alright? This is not gonna be a proper rectangle, or the image which the user provides is not a proper rectangle. So for that, we have the approximation method. So the first is dealing taking another variable, okay, in indentation error. Alright, so I take a variable that is peri, and over here let me use its arc length. Yep. Alright, so here I pass in whatever contour we are dealing with and a parameter true. So this true signifies that whatever, the four sides they are basically closed, and they do not have an open ending, or an open escape. So it is a closed shaped polygon. So now I'm gonna use this variable approx, and using CV2's approx polydp method, I'm gonna approximate the contours, initializing or keeping that in mind that they are basically rectangles. Even if they are not proper rectangles, they work with it. Now I'm going to use a value over here that is 0.02. Now that is very experimental. I'm multiplying it with the value I had over here, that is the arc length of each and every contour. So that is very experimental. You need to experiment around with your image and see what suits best for you, but for me 0.02 just worked fine, so I'm going to go with this one, and again true because it's a closed figure. So now that I have everything approximated, I need to ensure that the given contour which we got for the first instance is actually a rectangle and not some other figure. So how can we do that? Now if we ensure that the length of the contour which we received over here, alright, that is the approx. If that value, the approximate value of that particular contour is equal to 4, that means, and the image is sorted or the array is sorted, that means that this is the first contour with the biggest area having four sides. So all checkboxes ticked. Alright, so I'm gonna take another variable over here that is our screen contour, because this is the area of the document which needs to be scanned, and I'm gonna initialize it with approx. And as soon as I find that one contour which we need, or one contour which we need, we don't have to iterate further, we just simply need to break out of the loop. All right, so now just to check that that particular contour is working fine, let's just draw it out using the draw contour method. Okay, so yeah, image is basically the image we want that contour to act upon, and that is our resized image. And rather than CNTS, we need the name of our contour, and that is screen CNT in this case, and -1 because we want all the contours to be printed out, and the color of the contour and the thickness. All right, so yeah, cv2 dot im show. So this is basically the draw data. So let's pass in draw, and where are we drawing it? We're drawing it on the image. So I'm passing the image, and then we need to wait because it really disappears very quickly. Okay, so let me clear this terminal and see if we found. Okay, so I think we have some indentation error and that's in line. Okay, yeah, so it has to be, this should work now. All right, and there you go. Now we have got, these contours highlight that we have got the right region. But the problem with this document is that it has a lot of unnecessary surfaces over here which we do not need, and we need to crop these things out. Also, the angle which this is forming is not exactly perpendicular to a person's eye. So for that we need to get the bird eye view of just this part of the receipt. And for that, I went through pysearch.com and I found this 4point.py method. So I'll import the link in the description on how to use it and the explanation in the later part of the video. But for now, let's just import this 4 point file inside our doc scanner. Okay, let me close it and let's see what to do. So we have the image now and we actually need to get the bird's eye view of this particular image. So that can be easily done using this script. This is a Python script which give us the 4 point transform method, considering we have whatever image we need to use it on and the contour points. Alright, so this function, this 4 point transform functions, take two arguments, and there is some work done which we're gonna come on in the later part of the course. But for now, let's just import this one. So from 4 point, let's import the 4 point transform method. All right, okay, I've imported it twice. Let me just quickly comment this out. And now that we have drawn the contours, let's move on and actually get the bird eye view of the document and crop out the rest of the irrelevant part. Okay, so okay, so now I take another variable that is warped, and in this variable I call my 4 point transform method, which is situated inside another file. Now, like I said, it takes two arguments. Now, the first is the original image. Now, why did I not use my image? Because this is the resized image, and I need to return the user the original image which the user sent, alright, which is saved in the original file. So I pass in the original method and I take my contour which needs to be drawn, and that is the screen CNT one. But I need to reshape and resize this contour because this is basically based on a resized image. But now, since we have to deal with the original image, it has to be multiplied by the aspect ratio which we dealt with in the previous part of this course. Alrighty, so now that we have this, we need it to be reshaped in the form of a numpy array, that is a 4 by 2 numpy array. Now, why are we doing this? So if you go back to the picture, this is a square. It's a rectangle, right? And every rectangle has four sides. And every sides have two coordinates, that is their x coordinates and the y coordinates. So the new contours have to be reshaped in the form of a 4 by 2 matrix with every point having both their x's and y values. And they are also going to be useful in the later part where we're going to discover more that what this 4 point transform method does. Alright, so I have reshaped these screen contours and now I need to multiply them by the ratio, because earlier we diminished the ratio and now we need to cover up in order to get the original image. Alright, so that's our warped image, and let's just see if this works fine and everything is imported correctly. So yeah, let me just remove this draw contour method, and rather than draw, let me pass bird as in bird eye view, and rather than image, let me pass in warped. And yeah, let's see if this works. We are all the way here, and there you go, we have successfully gotten rid of all the impurities or everything which was not needed, all the irrelevant things out of this particular image, and we have almost completed building our document scanner right here. Now, jumping back to this 4 point transform method right over here. It basically has these two functions. First is the 4 point transform method, which actually does the calling, and the another one is the order point method. So as you can see from the comments, and you can even check out the documentation, it's pretty nice and they've explained it very nicely. So first of all, we need to order points. Why do we need to do it? Because in this image there are these multiple points, all right, and first point can be this, the second point can be this, but we need it in the form of a proper manner, all right. We need first this point, then this point, just for the sake of convection, then this point and the convention, and then this point. So that is what is done in this order point method. Using the arguments and considering the x and y coordinates, we have calculated that which point is going to be which. First they have calculated the bottom right points and the top left points, and then they have worked with the top right points and the bottom left points. So after they have received all these values inside this rect, it's again a 4 by 2 array, because everything has x and y coordinates and it's a float type value. So it will sort, it's another sort function for the coordinates, so it's gonna sort all these values and return them in the form of direct. This is the calling function, that is the 4 point transform function. What it has done, this is these indicates top left, top right, bottom right and bottom left, and they have stored it in this particular tuple, that is rect, after ordering them. Now they have calculated the width and the height of these two images, all right. So this has to be reshaped. So in order for it to be reshaped, we need to have a new length and a new height, and we need the maximum of these two right over here. So if you have studied using basic geometry, the function that it's equals to under root y2 minus y1 plus x2 minus x1, sorry, y2 minus y1 whole square plus x2 minus x1 whole square, that is what they have done. Using that, they have calculated out the width, and using the maximum here, they fitted it inside the array. Now the first coordinates has to be 0 comma 0, because when we are dealing with this image, we want this part to be over here, and this coordinates are going to be 0 comma 0, and these coordinates here, right here, are going to be maximum width minus 1, because whatever width do we have over here, minus 1, and the y coordinates have to be 0 itself. So this is what this function is doing. This is returning our warped value, and when we run it, we get a bird eye view. We can apply multiple filters right over here. We can blur it, we can binarize it using some threshold functions, so that it gives us a better filter. But for now, you have learned how to use all of the things you learned previously and build your own document scanner. Also, we're gonna come up with more such fun projects sooner. So stay updated with the channel, like the video if you liked it, connect with me if you want to, throw your queries and doubts in the comment section, and I'll be more than happy to help you. Do try it out. I'm gonna put the code link in my YouTube description, so don't forget to check that out. And if you want to learn more about how this works and all the algorithms, do comment it out. Thank you so much for watching this video. See you in the next one.